Alright guys, so part 3 of Herons proof is what we've come up with is an expression for the area of a triangle, and we know that Herons formula uses this expression ultimately where S is a semi-perimeter. Okay, you got to remember that S is a semi-perimeter. There's that. Maybe I'll copy that down here. A plus B plus C, and that's S. Alright? So S is A plus B plus C over 2. So what we need to do is we need to figure out how we can turn these expressions, these 4 expressions, into S, S minus A, S minus B, and S minus C. So what we're going to do, we're going to look at them individually. So first we'll start here. A plus B plus C over 2. Well, that looks familiar. That is S. Alright, so let's go ahead and simplify. So here we've got A plus B plus C. Maybe I'll use a different color for each. A plus B plus C, that's equal to S. So let's look at these next couple components here. Here's my next component. I've got A plus C minus B over 2. I need to turn that into, in this case, we've got a negative B, so I need to turn that into S minus B. Well, I can do that. I can rewrite this expression, keep it equivalent, as A plus B plus C, but in order to get a negative B, I've got a positive 1B here. I need to subtract out a 2B, and this whole thing is going to be under or over 2. So when I do that, I know that this portion of it is S, so I can break this apart into 2 separate fractions and get S, and what I'm left with is minus 2B over 2. My 2's cancel, and this ends up being S minus B. So that's that next component. So now I have an S and an S minus B. So now I'll work on, very similar fashion, I'll work on the next couple here. Here I've got a negative A. So I got to turn this into an S minus A. Well, I know I need to get an S out of it, so A plus B plus C is going to be S. But again, we need to keep it equivalent, so I need to subtract out a 2A. Break it apart into 2 fractions. The first part is A plus B plus C over 2, otherwise known as the semi-perimeter. And then what I have left over is minus 2A over 2. My 2's cancel, and I end up with S minus A. So there's my S minus A. I've got an S minus A, an S minus B. The last part is going to be my S minus C here. Again, we're going to use that same little trick in order to rewrite this. So that I can eventually get an S minus C. Here's S, break it apart into 2 fractions. And when I do that, my 2's cancel and I end up with S minus C. So here's my last term. So ultimately we end up with Herons formula through that little trick. So my area then ultimately is the square root of S times, I'm going to reorder here so that it reflects Herons formula. S minus the side length of A, S minus the side length of B, S minus the side length of C, and there's Herons formula. So our conclusion, I'm not going to write this because my pen's slow and it would take 20 minutes, but our conclusion is that therefore, for a triangle with side lengths A, B, and C, the area of that triangle is equal to this expression.